So today we're going to use NEBaseChanger and design some mutations for our protein. I'm just going to show how to do this. So we have our plasmid map in APE, a plasmid editor, and this is the whole plasmid. This is our gene sequence here, and so uh, we've got a signal sequence in this green, the PEL-B coding sequence, and so we're going to skip that one when we're naming or numbering these residues, although um, yeah, we can decide on how we want to number each residue for now, but that's just what we have um, as of right now. And so highlight the entire sequence. So we're starting at this start codon, this methionine, all the way to the stop codon. I'm just going to copy this, and we put this into XPaSsy's translate tool. I like this output the most. It's on compact settings, and we can, yeah. So let's see. Just put your sequence in there. Output format is compact. Translate, and we can copy this. And I put this in a text editor. This is Sublime, and it's important to put everything on one line. Otherwise, you're going to be counting the returns, the new lines as a character, and what this, so you can see that we're all on one line. This is the wrap text, so that's why it appears like it's on 3 lines, but yeah, 4 lines. And so what this allows us to do is we can highlight the sequence, and we'll get the number of characters selected on the bottom. You'll see that down here, 114. So what I want to do is highlight, I want to mutate the 117th serine. So right now I highlighted 116 characters. And this is our serine right there. So 116, I want to just look at, we got to go back to the DNA sequence because that's what we're working with. And what we'll do is we'll just take this, let's see, I'm getting ahead of myself here. So we have our protein sequence. Let's throw this chunk, doesn't really matter too much. We're going to throw this into the NEBaseChanger website. Okay, enter new sequence. So I just copied this, and you don't need to put in the whole chunk. What we're doing is we're amplifying from that mutation. You're having 2 primers overlap in this region, and they're amplifying the entire vector in opposite directions. So I'm just going to name this pizza. This is some of our sequence there. Okay. And now what we want to do back here, and we want to find the 116th. I want to count up to that serine. Okay, so 116 times 3, right? Because every nucleotide, there's 3 nucleotides in each codon, and so that's why we want to find this number. It's 348. Maybe you're better at math out of your head than me. Google Calculator is always helpful. And so what we're doing here is, again, highlighting, and at the top we're getting our length updated in real time. So we go 348, 647, 48. Okay, and we're now at this. So up here in 8, you'll see the length being counted. Okay, and then so we're at this TCC G. TCCCAGGG, whatever. We can just highlight some of this, copy it, and put it into our NEBaseChanger. There's a find function, paste that, and we find it right away. Okay, and this is, I just want to confirm that this is TCC, that TCC codes for the serine that we want. So we can look at a codon table. This is just finding a random codon table on Google. So T, C, and C, serine right there. Okay, and for purposes of this video, we're going to mutate this into an alanine. And so alanine is in this gray. The quickest, the simplest way to change this TCC into an alanine codon is replacing the first T into a G. Alright, so what we can do is go back to this NEBaseChanger. We want to just highlight, we're going to highlight this T, okay? Change it to a G, okay? And then that puts us, it creates a couple different primers down here that we can use, and I want to make sure that this is giving us the right mutation at the right spot. So if we go back to our protein sequence, in fact, I'm just going to bring this down here. Okay. Let's see. Luckily, I still have this highlighted. This is their serine. Okay, so we're on GHSQ. Okay. And so we want to find that in these. This is the translation sequences here. Translate sequences, and we want to find this GHAQ, right? And it looks like we're right here, GHAQ, and then G. All right, we can read that a little bit further as well. VDIVGHAQ. Okay, so this matches. This is the frame that we're interested in, and we see that we have our alanine in substitute of the serine, which is exactly what we want. So we can then take these primers here, put them in order form with IDT DNA, and then use these for our if we're introducing the mutation into our sequence, our protein.